Hello to my favorite Algebra 2 class, to Bree, to Laura, to Cassie, to Rachel, and to all of you out there in TV land, which of course it's not TV land, YouTube land, who have stumbled upon this wonderful class led by Miss Fliegelschnartz. We're now on section 2.6. We're going to do some interest and mixture problems. But first, can you tell me what it is that mice wear when they play? Pretty bad if you can't remember the lame joke of the day. What is it that mice wear when they play basketball? Well, of course they have to lace up their squeakers if they're going to play, now don't they? So we are in section 2.6, and we are going to do an interest problem. And interest has a formula. Interest is equal to principal times rate times time, where I is the interest earned, where P is the principal on account, principal deposited, rate is the interest rate in decimals, interest rate in decimal form, and the time represents an annual rate, or it's 1 year. Now, interest is what the bank or a corporation pays you for the privilege of using your money. Sometimes they pay you a high rate of interest. Sometimes they pay you not so high of rate of interest. Currently in our economy, the interest rates are very low, so you don't get much of a return on money that you have deposited right now. Principal is, if I'm going to deposit $500 in the bank, the rate right now I might get 1% interest or 2%. The book's probably going to range between about 5 and 8% interest. Time represents 1 year. So if you have less than 1 year, if you have 3 months, that's 1/4 of a year, so it would be 0.25. So this is the formula that we're going to use. This also has a way that you can set up a table. And that's exactly what we're going to do with this first example here. It's example problem number 1 for 2.6. And we're going to figure out what it is they want us to find. But first, we know that interest is equal to principal times rate times time. So we're going to go ahead and divide our table up in this fashion. Let's read our problem example number 1 on page 64. And it says, Mr. Jameson invested $9,500 in 2 accounts. He makes $904.50 annual interest. How much did he invest in each account if one account pays 9% annual interest and the other pays 10.5% annual interest? Well, first off, let me tell you right now, 9% and 10.5% interest doesn't exist right now unless you're in some sort of a very risky business. But we'll go along and go ahead and play along with this particular problem. So we're going to have a certain amount that was invested at 9%. So this is the amount invested at 9%, amount at 9%, and then we're going to have the amount at 10.5%. Now, how long does it say that he's invested this money? Well, it says he makes $904.50 in annual interest. So that tells you that he has left this money in his interest-bearing accounts for 1 year. So the time is 1 for both of those. Both of those amounts were invested for the same time period. How much did he invest in each account? He has $9,500. That would be the amount of principal that he has. Well, does he have it all at 9%? No. Or maybe he has 4,000 at 10.5%. Well, we don't know exactly how much he has, but we do know a relationship that we can write here that will show us with variables the amount of money that he has invested. So let's just say, let's let X be the amount. Is that working? Can't see. Amount invested at 9%. So how much did he invest at 9%? We don't know that, but we do know that we're just going to call it X. What's the total amount that he invested? Well, our book tells us that he invested $9,500. So if he invested a total amount of $9,500, and we know that he invested some unknown amount X at 9.5%, at 9%, I'm sorry, then if we take 9,500 minus the amount that he invested at 9%, which we're representing with X, that is the amount that he invested at 10.5%. So that's the amount invested at 10.5%. Okay? Principal, rate, times time. What's our rate? The rate is 9%. Is that 9? No. Remember, percent is 9 per 100. 9% is 0.09. So what is 10.5%? 10.5% is 10% and another 0.5%. Let me make sure that I've got that correct. Yes. That's 10%. It's not 1/5 because that would be 15%. 10.5%, that's 10.5 divided by 100, is 0.105. This right here is really tricky. Make sure that you're paying close attention and converting your percents into decimals correctly. Okay, this is the rate that he earned. This is the principal. How much did he invest? How much money did he actually put into the bank, put into the investment, put into the CD, whatever it is? At 9%, it says he invested X dollars. At 9%, he invested $9,500 minus X at 10.5%. How much interest did he get? Well, interest is principal times rate times time. 1 times this, 0.09x times x is the amount of interest that he's earned here. 0.105 times 9,500 minus x is the amount of money that was invested at 10.5%. So if we take the amount of interest that he earned at 9%, the amount of interest that he earned from his deposit that was made at 10.5%, those two quantities added together is going to give to us the total amount of interest that he earned. 9,500, I'm going to go ahead and move this over. Looks like my camera got knocked. The interest that he earned at 9% plus the interest that he earned at 10.5% is equal to the total amount of interest he earned, I believe $904.50, is equal to 904.50. Now I'm going to do what they call clearing the equation of decimals. It just is a mess when we're multiplying by hundredths, thousandths. We're going to multiply through the equation, or you can think of it as multiplying both sides of the equation. by the power of 10 necessary to convert all of these decimal numbers to whole numbers. And those of you who are taking chemistry, this is what we were talking about a lot with multiplying by powers of 10 in the metric system. 2 decimal places here, 3 decimal places. We're going to need to multiply by 1,000 to get rid of our decimal places. Now this is a shortcut way that I'm using since I'm running out of board space here. What this means when I have the entire equation bracketed is that I'm going to multiply both sides of the equation, every term within there, by 1,000. 0.09x multiplied by 1,000, the decimal point moves 3 places to the right, you end up with 90x plus 105 times 9,500 minus x is equal to 904,500. Big numbers here. 0.09 times 1,000 is 90. 0.105 times 1,000 is 105. Why didn't I have to multiply this? Because I had 3 factors, 1,000 times 0.105 times this. Multiplied the a and b together. Then we multiplied again by the quantity inside the parentheses. 904.50 multiplied by 1,000 is 904,500. So now I wish that I had my calculator handy, and I do. Thank you, Lord. So I'm going to have 90x plus. Now since I'm using the calculator anyway, couldn't I have just done a hit? Left it at the decimal point? Yes, you could. But a lot of the time when you multiply through to clear your equation of decimals, you're able to do the arithmetic pretty handily in your head. 105 times 9,500 is 997,500. 997,500 minus 105x is equal to 904,500. Y'all tracking with me? 90x minus 105x negative 15x is equal to 904,500 minus 997,500. 904,500 minus 997,500 gives us a negative 93,000. Negative 93,000. We're going to divide both sides by a negative 15. Can you put my finger there? Okay, both sides by negative 15 divided by 15 is 6,200. Now, what is my 6,200? Let me get a different marker here. So I have x is equal to 6,200, 9,500 minus x is equal to $3,200. $3,300, sorry. And this is the amount that's invested at each percentage. 6,200 at 9%, 3,300 at 10.5%. Now, if we actually calculate these, we should end up with $904.50. So let's see what we get. Okay, this first one is 6,200 times 0.09 is $558. $558 at 9%. This next one, 3,300 times 0.105, is not the right answer. 3,300 times 0.105 is 346.50. At 10.5%, you total those together, 50, carry 1, 509. Supposed to be 904. What did I do wrong? Right there, 6 and 8 is 14. I didn't have 1 to carry. $904.50. What you need to remember here is that interest is equal to principal times rate times time. You need to remember that time is expressed as one year, an annual year. It doesn't have to be January through December, but it's 12 months, so you have to adjust this number for anything other than annual interest. The rate is going to be given to you in all likelihood in percentage form. You have to convert that to decimal form. You're going to have solve for one variable in terms of another variable. And then you can go back and check your work when you're finished. And that's the end of a good example of how you solve interest problems.